For today's lesson, we're talking about radicals. Another term that you might have heard for these are roots. And let's just start today with our notes and getting this key definition down. So go ahead and pause your screen and copy it. But a radical equation is an equation with a square root or cube root, etc. And that etc. implies that we can go up to fourth root, fifth root, sixth root, any number we can go up to root. After you've unpaused your screen, let's go ahead and fill out this table as well, because the two main roots we see are square and cubes. These are the ones you're most familiar with. And recall that a square multiplies by itself. We use these all the time. An example of this would be 3 squared. If we had 3 squared, simply equals 3 times 3, and that equals 9. Now, the simplest way in my mind to think about square roots is that we're simply going the other way. So if I take the square root of 9, okay, all that does is give me the base that we had for our exponents. The square root of 9 is 3. Notice how they're just opposites. 3 squared equals 9. The square root of 9 equals 3. So cubes works a similar way. If I take 3 to the third power, okay, 3 cubed, that's 3 times 3 times 3 equals 27. I can find the cube root of that if I go in the other way. So the cube root sign is a little bit different. It looks like the square root, but has this little 3 that sits inside that hook. If we take the cube root of 27, we'll get exactly what that base was that we cubed, and we'll get 3. And notice how the square root sign doesn't have a number in the hook. That's because we use this one so frequently that it just has turned into convention that we don't write the 2. But for every other root or radical that we use, the cube roots, the fourth roots, the fifth roots, if you're looking for those, you want to write that number in the hook. But today, we're mainly focused on our square roots. So with this, I want us to recall some of our perfect squares so we have this as reference. This is going to be crucial to our activity today with writing in simplest radical form. And we're just going to build up this table of square roots by counting from 1 to 2, 3, 4, 5, 6. And we could go on and on forever if we wanted to, building up these perfect squares. But we're going to stop after 6 today. So to find the square of that, I simply raise it to the second power. Okay, and 1 squared is going to be 1. Now recall that square rooting just goes the other direction. Okay, so my square of 1 was 1. So if I wanted to take the square root of that answer, square root of 1, that'll simply equal 1. Let's see how this plays out with 2. If I take 2 squared to the second power, that equals 4 because it's 2 times itself. And if I take the square root of 4, I get back down to 2. Repeat that for 3. 3 squared equals 9, which means that the square root of 9 equals 3. 4 squared equals 16. So the square root of 16 equals 4. 5 squared equals 25. So the square root of 25 is 5. And 6 squared equals 64. So the square root, oh wow, oops, it's not 64. It's, my apologies, the 6 squared is 36. And the square root of 36 is 6. I knew I was doing something wrong as I said that out. Now notice how all of our bases on our squares, so 6 squared, 5 squared, 4 squared, they show up as our answer in our square roots, 6, 5, 4. The square root simply undoes that square. It goes in reverse, just like dividing undoes multiplication. So we're going to use these perfect squares to rewrite some expressions in what's called simplest radical form. So go ahead and pause the screen and get this definition down of what simplest radical form is. But it basically means we rewrite the expression so that there are no more square roots, cube roots, etc. left to find. It's actually easier to see this through an example than it is to just talk about it. So in example 1 here, we have the square root of 8. And we want to rewrite that in simplest radical form. We're going to use this property of square roots up here that I've just added to guide our process, okay? And that is if we multiply two different square roots together, we can actually combine that multiplication underneath the square root. Let's see how this happens. So if I have 8, I first want to break it down into all of the factors of 8, and that's what multiplies together to give me 8. And what we want to do is we want to avoid using the number 1 here, because the number 1 is just going to get us into a repetitive process. So if I think about other things other than 1 that multiply to get into 8, my only other options are 2 and 4. So I'm going to write underneath here, instead of the square root of 8, I'm going to write the square root of 2 times 4. Now nothing's actually changed here yet, right? Because 2 times 4 equals 8. So we still have 8 underneath our square root sign. Okay, but once we have these two separate numbers underneath the square root, we can actually split them using that property I just added. Okay, so square root of 2 times 4, I can rewrite that with separate square root symbols. Now I have the square root of 2 separate times the square root of 4. Okay, well, if we think back to our perfect squares, we actually know what the square root of 4 is, don't we? We know it as 2. So we can rewrite this again as the square root of 2 times 2. Here we simplified the square root of 4 here and rewrote it as 2. And we can't take the square root of 2, all right? We can't take the square root of this one, so we're going to leave it as is. So otherwise, if we put it into our calculator, it gives us a long, nasty decimal. All right, we're just going to simply rewrite our answer so it's a little cleaner. We're going to put the 2 out front and have 2 times the square root of 2 as our final answer here. Let's see how this comes into play with one more example, okay? If you want to try this on your own first, go ahead and pause your screen. Otherwise, we'll talk through it. But again, we're writing in simplest radical form. This one's a much larger number, okay? And I like to think of this in multiple steps, and usually dividing by 2 is a really, really good start. In this case, it might actually help us out really well. So we have the square root of 72, and I divide that by 2. Okay. I could break that down into 2 times 36. So again, I haven't changed anything underneath really. 2 times 36 is equal to 72. I'm just writing it in a different way. Then we can go ahead and split our square root signs. Square root of 2 times square root of 36. Okay, we know we can't take the square root of 2, so let's just rewrite that. We ran into that in the last example. But can we take the square root of 36? Yeah, we can. That there, from our perfect squares list, was simply 6. So there we have the square root of 2 times 6. And finally, let's just rewrite it with that 6 out in front. So we get 6 times the square root of 2. To finish out the notes today, there's a summary spot at the bottom. Please put in your own words so that you can process this and walk away with this in a way that you will remember. Stop and write. How do you write an expression in simplest radical form?